Welcome to Agents in a Nutshell. Today, we're cracking open the Model Context Protocol. Forget the marketing hype, we're here for the architecture and the spec.
So let's just get right to the engineering pain this is supposed to fix. If you've built anything with agents, you know this pain. It's the N by M integration problem. Every time you have a new agent and every time you have a new tool, you're building another bespoke, brittle adapter. It's a combinatorial explosion and it just doesn't scale. It's a huge tax on just getting anything done.
So that begs the architectural question, right? Instead of building this endless spider web of one-off connectors, can we define a common language, a standard interface? Kind of like what the language server protocol did for IDEs and compilers that just lets any tool talk to any agent host.
Okay, so let's get into the specifics. This is where the Model Context Protocol, or MCP, proposes to be that standard.
At its core, MCP is not just another stateless REST API, and that's really important. It's a stateful session layer, and it's built on a foundation we all know, JSON RPC 2.0. Now, the key terms to lock onto here are stateful and capability negotiation. We're going to break those down, because that design choice has massive implications for how agents and tools can actually interact.
You're going to hear people call this the USB-C for AI. And honestly, it's a pretty good analogy. The whole idea is a single, open standard that's meant to replace this fragmented mess of proprietary, incompatible connectors. It's all about interoperability. So, why should this actually be on your radar as an architect or a tech lead? What's the real architectural value here, beyond just, a bit of convenience?
Well, it really boils down to sound system design. For starters, it decouples the AI host from the tool implementations, which is a massive win for maintenance and modularity. It gives you clear security boundaries between your components, and it standardizes the patterns for both local, high-performance communication and your typical remote HTTP services. The end goal here is a truly composable tool ecosystem.
All right, now for the fun part. Let's get under the hood and break down how this thing actually works.
The architecture splits everything into three very distinct roles. First, you've got the host. That's the AI application itself. Think your IDE or some desktop agent. The host is responsible for managing multiple clients. Now, each client is a little connector inside the host that maintains a dedicated one-to-one session with a single external server. And that server, well, that's the program that's actually providing the tools and the data. And how do they talk to each other? Well, you get two main options for the transport layer. For local processes, it uses stdio, just standard input-output. This is extremely high performance for inter-process communication, zero network overhead. For remote services, it specifies a Streamable HTTP transport, using standard post requests and server-sent events. And of course, it supports your typical auth methods. And this JSON blob right here is where the entire session begins. It's the initialized handshake. But don't just gloss over it. This is way more than just a simple connection request. What's inside that payload is absolutely critical. This is the capability negotiation. It's not just about connecting, it's about forming a contract. The client and the server explicitly declare what they can do, things like invoking tools, subscribing to data resources, or even asking the user for input. This exchange establishes a formal, session-specific contract that says exactly what's allowed for the entire life of that connection. Okay, now this is where it gets really interesting. Look at how MCP defines primitives for both sides of the connection. Of course, a server can expose things like tools, which are just executable functions, or resources, which are read-only data. But here's the critical part. The client can also expose capabilities. A server can actually ask the client's host to do things for it, like perform LLM sampling. Basically, hey host, generate some text for me, or elicit input from the end user. This makes for some really complex bidirectional interactions. It's a two-way street. And the whole model isn't just request-response. It's designed for event-driven updates through these one-way JSON RPC notifications. So for instance, if a server's set of available tools changes in the middle of a session, it can just blast out a tools/list changed notification, and all its connected clients get updated instantly. No polling required. It's properly event-driven. So, the tech is sound, for sure. But the crucial question is whether this is just a spec on a piece of paper or if it has any real-world traction and, a viable governance model. The governance model is absolutely critical for any standard. Anthropic started this and open-sourced it, but then they did the smart thing. They donated it to the Linux Foundation. Now it lives inside the new Agentic AI Foundation.
And that move to a neutral, vendor-agnostic home, well, that's a huge step toward building trust and getting wide industry adoption.
And this is not happening in a vacuum. There's already significant industry buy-in. You've got early adopters like Block and Apollo. Key dev tool vendors are already integrating it. We're talking Zed, Replit, Codium, SourceGraph. And then, the foundation itself includes the heavy hitters. AWS, Google, and OpenAI are all members. The protocol is also designed with a formal way to be extended. A really powerful example is something called MCP Apps. This extension lets a tool return not just some text, but a fully interactive HTML UI that renders right inside the host application. It's pretty clever. It combines the tool and resource primitives using a special UI/scheme to serve the interface, which then runs Sandbox for security.
So where does this all go in the next 5 years? I mean, the technical foundation is solid, but we all know success depends entirely on adoption.
You can really see 3 likely outcomes here. 1, it becomes the dominant standard. You know, the Kubernetes of agent interoperability. 2, it finds a very successful but maybe more limited niche, kind of like the language server protocol did within DevTools. Or 3, it gets superseded by a competing standard and becomes a footnote. It happens.
And the stated ambition is crystal clear. The co-creator David Soryapara put it plainly. The goal is to become the de facto standard, so you can build something once as a developer and it just works across any client. That's the dream, right?
Which really leaves us with the critical question for the entire industry. Is this effort finally going to consolidate the fragmented agent ecosystem, or is it just going to add another contender to the ongoing protocol wars?
Look, if you take away one single thing from this, it's this. MCP's core technical differentiator is its stateful session model. The entire interaction is framed by that initial explicit capability negotiation. That creates a robust contract between the client and the server. That right there is the defining feature.
And that's MCP in a nutshell. Thanks for tuning in.